So if you were expecting a webinar today on using GenAI digital teaching simulations as practice basis for eliciting student thinking and science, you are at the right place. So that's what we're going to be delving into today. And we're all really excited to be here to facilitate and host this NARS online webinar with you today. If you go to the next slide, we have people joining from Greece, which is great. And also from London, we have people all over the world, which is very exciting. So 4 of us today will be here as your facilitators of the webinar. I'm just going to give each of us a brief moment to introduce ourselves so you can get to know kind of who we are. And then you'll be getting to know one another during the webinar because you'll have chances to hear from one another ideas and also meet in some breakout rooms to talk to one another as well. But Trisha, why don't you go ahead and get started with introducing yourself?
Okay, sure. Thank you so much, Jamie. Hello, everyone. Thank you so much for joining us. I'm delighted to meet you all. I'm Trisha Maxwell. I'm honored to be co-presenting this workshop for you guys tonight. I work at ETS, where I've spent the past 7 years designing innovative tools, performance tasks, large-scale science assessments, and doing research in science education. Before that, I spent 13 years as a high school teacher for AP chemistry and other science courses, as well as working in industry and analytical chemistry research. The digital simulation and its potential applications we're going to be exploring tonight is something I'm excited to share with you all. It's part of my ongoing passion for supporting science education professionals and creating meaningful spaces for both teachers and student learning in science. I'm looking forward to diving into this with you and hearing all of your thoughts. And now I'll turn it over to my colleague, Shreyashi.
Thank you, Trisha. Hi, I'm Shreyashi Haldar, and I'm working as a research project manager at ETS. I'm currently involved in projects that leverage GenAI in digital teaching simulations to enhance the practice of science and mathematics teaching skills. My expertise also includes improving the online learning environment for both pre-service and in-service teachers, which also aligns with my current work. Today, I'm looking forward to having a conversation with all of you about these advancements and learning from your insights as well. Now, I would like to hand it over to my colleague, Indira.
Thank you, Shreyoshi. Hello, everyone. Glad to meet you all. I'm an ex-agricultural scientist, and I moved on to training teachers, both pre-service as well as in-service teachers in science education, in science teaching and training. And science teaching has been a passionate journey. And here in ETS, I'm an assessment specialist and also looking into a little bit of data analysis with the GenAI teaching simulation research project. With that, I hand over to Jamie. Jamie, over to you.
Great, thanks so much. So I'm Jamie McCaskill. I'm currently a managing principal research scientist in ETS's Research Institute. And the work that we'll be sharing with you today and the materials and the tools come out of a research program called the Teaching Pathways Research Program that I've been co-directing for almost, I guess now a little over the last 2 years. And I'm very passionate. I was a former teacher myself and very passionate about how we can support teachers in developing their practice and learning how to engage in ambitious teaching practices. So the GenAI teaching simulations are one tool that we think has a lot of potential to do so, and be interested to see what you think as we engage in this webinar together today. So with that, if you want to move, we first want to just start. I think Trisha had, Trisha, if you want to move to the next slide, she'd sent out earlier on an email, and in just a few slides, you'll get a QR code and you'll have a link to Padlet. We'll be using this online Padlet as like a shared collaborative workspace today. But we wanted to start by learning a little bit from you about your previous knowledges, experiences, and familiarity with digital teaching simulations. So there's 3 questions we're going to have each of you respond to get a sense of kind of your background in this area. And the first question is, so you can already start thinking. In a moment, we'll have a QR code and a link that will allow you to actually enter your responses. That I want you to think about are, what are the first 3 words that come to mind when you hear the term digital teaching simulation? And so that's the first question. The second question, if you go to the next slide, is we're really interested in how familiar are you with using digital teaching simulations to support science teacher learning? That can be from not at all familiar. So maybe this is the first time you're hearing about digital teaching simulations, not quite sure what they are or how they can be used, to all the way to the very familiar side where maybe actually you've developed and have used and integrated digital teaching simulations in different science teacher learning contexts, right? And then we have some responses in between. And then the third question that we're going to have you respond to is just about your perceptions about using digital teaching simulations. And we have a quote here that we'd like you to say kind of to what extent do you agree with this statement? Digital teaching simulations are productive tools that can be integrated into various science teacher learning settings to support teacher learning and development. And that will be from strongly disagree to strongly agree. So if you go to the next slide, this will be where the QR code is. So you can either use your phone or you can use a link that Shiroshi just posted in the Zoom to go to the Padlet. And in the Padlet, you'll be able to respond in the Padlet to all three of these questions. So Trisha's going to show you right now what that looks like. So when either you do the QR code on your phone or you, and she'll show that QR code in just a moment. She's just going to go to the Padlet for a quick second to show you. Can you go to the Padlet there, Trisha? Yeah, okay, great.
Sorry, it advanced, and so give me just a second. I'll open it up again. There we go. It just
Okay.
advanced on the
No problem.
into the thing.
So when you either
thank
click on the link in the Zoom window or the QR code, which Trisha will show in just a moment,
Mhm.
this is what it will look like, and you'll be in the intro column for goals and key activities. And you'll see there on the left in that column, there's a place to say, what are the first three words that come to mind? And if you see there's a place that says add comment. So if you can just show them where it shows to add comment, Trisha, no, right in the little box. Oh, okay. Oops.
Right here.
Okay, right in the little
Yep.
box there, you can add your three words that come to mind when you hear digital teaching simulation. Then if you go underneath that one in the Padlet, you'll see the second question that you can respond to. So all you do is just toggle down there about your familiarity, and you can choose one of the four options. And then if you go down, and then you'll click vote, and then you can have your perceptions. So if you can go ahead, give everybody a moment. We'll give you maybe 2 minutes. You can see people already started voting and adding, which is great. I'll give everybody 2 minutes to go to the Padlet to respond to those three questions, and then we'll take a look at that across. And I can see Stephen and Jose already added, which is great, to the first question. And then can you just go back to the QR code, so if people wanted to do that on their phone, they could do that instead of using the link. So I set my timer for 2 minutes. And if you're having any trouble, just speak up or post in the Zoom chat so we can know to help you. I see some additional votes coming in. And I appreciate some of the words I see that people are adding about what they think of. So it looks like about half of the people have been able to respond so far. So I'll give you about 1 more minute for the rest of you to hopefully you can get in there and respond to those three questions. We'd love to hear from everybody. And if anybody's having any challenges getting in there to the Padlet to respond, please do speak up and let us know. About 30 more seconds. Good, we have 7 votes, looking for about 11 across all of the questions. About 15 more seconds. Good, we have 10 votes now, which is great. Okay, Tricia, let's go ahead and go to the first question so we can take a look at folks' responses about some what you thought about the first three words that come to mind when you hear the term digital teaching simulation. I already saw one person said cool, but so we have folks talked about practice, feedback, and improvement. similar to the FAT simulations, but learning about pedagogy teaching, ? Customizable animations and cool. Distance engage and tech enhance. We have some ones about virtual classroom learning. Reflection, pedagogy, and feedback. So those terms feedback and pedagogy coming up a few times. The word virtual, student engagement, and interactive. So this idea that, right, it's interactive, that there's like some communication that's happening. There's another one for interactive, that and multi-purpose. And then we have someone said distance, self-paced, and tech heavy. Are there any others there that I missed? So we see some commonalities in terms of virtual, in terms of engagement, being interactive, and the focus on pedagogy and teaching. Great. And then in the next one, if we take a look, so this was the question about how familiar you are. So let's take a look at what it looks like across the folks that are here. Okay, so we have folks that kind of range from not at all familiar to somewhat familiar there, but we don't have anybody that's very familiar, which is great. That I'm glad everybody's here that are maybe interested in learning more, and hopefully we can broaden ideas and understanding about kind of what digital teaching simulations are, how they can be designed, and how they can support science teacher learning, the possibilities there. And then the last question in terms of the folks that are here, to what extent do you agree? Oh, so there's actually on the agreement side, which I'm actually surprised, because usually you have some folks that maybe are maybe disagree, but that makes a lot of sense, right? I guess maybe you wouldn't want to spend your time coming to a webinar on something that you don't think maybe has potential with that. So we have kind of, about a 50-50 split, with a little bit more to the agree side that strongly agree about how digital teaching simulations can be productive tools that can be integrated into different science teacher learning settings to support teacher learning development. We're really hoping today to kind of broaden and support ideas about what that could look like in the settings in which you work, and in the, the teacher populations that you work with and collaborate and engage with. So thank you so much for responding. If we want to go back to the slide deck, I just want to highlight before we start jumping in here today, if you want to go to the next slide. So this is a broad overview of the goals for our webinar today. So we have 4 main goals. So we're hoping to spend some time addressing each of the goals through different learning activities that we'll be engaged in together. So our first goal is trying to better help you learn about and better understand what GenAI digital teaching simulations are and how they can be designed. And when we say GenAI, we mean generative artificial intelligence. So GenAI is our shorthand way for that we use, the acronym that we use. You will actually get a chance to prepare for and engage in a GenAI digital teaching simulation today, just like a teacher would in a professional learning setting. So you'll get a chance to experience that and see what it's like from that perspective. You'll also have a chance to analyze a transcript from a GenAI teaching simulation session, the same one that you'll get a chance to prepare for and engage in. And you'll get to analyze the transcript for evidence of different teaching moves that a teacher had used to practice eliciting student thinking about a science topic. And then at the end, we'll spend some time together brainstorming ideas for ways in which GenAI teaching simulations could be productively integrated and used within different teacher learning settings to support science teacher learning. And this is where we really want to hear ideas from you and about the settings in which you work and the teacher populations and groups that you collaborate with and support and work with together, and how these types of tools could be useful in those varied settings. So those are our 4 main goals for the webinar. And then if you go to the next slide, this just kind of lays out our main activities that we'll be engaging in together to address those 4 goals. So our key activities today will be in kind of 5 main sections, I guess, so to speak, of the webinar. So first, we'll start out by telling you a little bit about background about digital teaching simulations and give you a chance to actually engage in as a learner yourself and try out the digital teaching simulation. The second activity is we'll give you a behind the scenes look at actually how we design the GenAI teaching simulation that you'll get a chance to engage in today, and give you a chance to ask questions and reflect on that process to kind of see like how we actually built the actual tool and have been using it to support science teacher learning. In the third part of the webinar today, we'll get a chance to where you'll engage in some analysis of a transcript from the same GenAI teaching simulation and think about and analyze that transcript for different teaching moves that were used by one of the teachers to elicit student thinking in that simulation. And then in the fourth part, you'll explore how GenAI teaching simulations and transcripts, possible ways they could be integrated productively in science teacher education. And then in the fifth activity, we'll finish with just some general Q&A, although we'll have that throughout all of those other activities, and we'll make sure to provide you with access to the webinar materials, including a whole set of transcripts that you could use in different ways. So you'll have access to those to use in different ways in the different science teacher learning contexts in which you work and collaborate in. So that's what our time together looks like. Trisha, Sureshi, and Deera, anything that I forgot to mention so far?
No.
No? Okay. So hopefully everybody has access to the Padlet. So here's a QR code that gets you access to the Padlet that Trisha was showing a moment ago. The link Shiroshi have posted earlier in the chat, but we'll use this Padlet, which is an online kind of virtual bulletin board to support collaboration and sharing during today's webinar. And so if you could just go there, Trisha, I just wanted to say a little bit about how it's organized so you can hopefully find where we are at any point during today's webinar. So it's organized, the Padlet is organized in columns. That first column that we were just looking at previously was the introduction one where you responded to some of those opening questions so you could get a sense of who was here and their familiarity and background with digital teaching simulations. And then we have one column for each of the 5 parts of the webinar today. So in part 1, where we'll talk about background about digital teaching simulations and give you a chance to engage in the simulations. You know, if you just want to go down, there'll be different questions in part 1 that you'll be able to see, and we'll direct you to which box at which time. So don't move ahead yet. So don't start answering questions prematurely. We'll let you know when we're ready to go. And then we'll be in part 2, part 3, part 4, and part 5. But I just want to make sure everybody has access. We'll walk you through and let you know where to be at which time. But we do ask that you don't prematurely move forward because there's some things we want to make sure that we're doing and talking about in like breakout groups and things like that. But I'll pause to see, does anybody have any questions? And also want to make sure if you don't have access to the Padlet or having any trouble getting access, please do speak up and let us know. Because we want to make sure that everybody's able to engage today. So any questions, comments, or trouble accessing the Padlet? Well, with that long pause, I'm going to say we're good to go, and I'm going to hand it over to Shiroshi. He's going to kick us off with a background about digital teaching simulations, and then she'll engage you in preparing for and actually trying out a GenAI digital teaching simulation.
Thank you, Jamie, and handed it over to me. And I would like to welcome all of you once again to our NERST virtual event. We are truly delighted to see you all coming together to learn, share, and engage with us. Please stay with us throughout this event. Your participation will make this event more valuable for us. As Jamie mentioned that we divided this whole event into 5 parts. So I will start with the background about and also the engagement with digital teaching simulations. Moving forward, next slide, please. So I would like to start with that why we are particularly focusing on GenAI digital teaching simulation. So earlier, Jamie asked you a question about how familiar you are with digital teaching simulation. Some of you said a little bit of familiar, not familiar at all. So I would like to talk a little bit more about it, providing you a more context about the digital teaching simulation. So the last couple decades saw an explosion in the use of mixed, augmented, and virtual reality classrooms environment for designing and delivering interactive digital teaching simulations that can support teachers in developing their instructional practices. So one such classroom, as you can see in this picture, Martian's upper elementary classrooms with 5 interactive student avatars could be for an example, we're showing this picture to you. So research has suggested that These kinds of simulated classroom environments can be used as practice spaces where teachers can try out teaching strategies, but in a low-risk environment where the complexity of teaching is purposefully reduced. Using digital teaching simulations can improve teachers' instructional skills and beliefs, and they can provide teachers with opportunities to try out a practice as many times as they need. The simulations are also quite flexible as they can address various instructional strategies such as eliciting students' thinking and facilitating students' discussion and teaching various science topics, not just science topics, but also other subject matters such as mathematics as well. However, most of these existing digital teaching simulations require a human in the loop to power the student avatars during the simulations. In the picture, you can see the student avatars. Those are actually controlled by a human behind the scene. So when a teacher enters the space, human must remain behind the scenes to control these avatars and initiate the conversation with the teacher, which is a major challenge of this current format of digital teaching simulation, which also limits the scalability of these digital tools as well. Recent advances in GenAI have resulted in new possibilities where GenAI can be used to power these simulations, removing the need for a human in the loop and increasing their potential for scalable and wider access of personalized learning experiences for teachers. Next slide. So earlier we talked about how digital teaching simulation provides teachers an opportunity to practice their instructional strategies. Now let's focus on one important element of those strategies, that is the teacher talk move. Teacher talk move is an intentional prompt or action designed to open up a classroom discussion that sets up a student to think, reason, share, expand upon their ideas, and deepen their reasoning in academically productive ways. Next slide, please. So you have heard me saying that in earlier slide that teachers can try out various teaching strategies within digital teaching simulation, such as eliciting students' thinking. And our event is also focused on how teachers can utilize GenAI teaching simulation to practice how to elicit students' thinking. So the reason we emphasizing elicitation is that when we talk about the core teaching practices, eliciting students' thinking is one of the foremost strategies we can think of. So what is elicitation? The intentional drawing out of student responses, ideas, and understanding through discourse. And why is this elicitation important? So create formative assessment opportunities for teacher that provide the best evidence of student understanding. And how does elicitation support teacher learning and practice? To improve teachers' abilities to attend to and respond to students' ideas in the moment and make instructional decisions about how to move learning forward. The next slide, please. So now I would like to share a brief overview of our recent development of GenAI digital teaching simulation. So our cross-disciplinary team has been working for a past year and a half to design and refine this digital teaching simulation to make it more usable for teacher practice. Within it, we have developed both science and mathematics tasks, particularly for elementary teachers. Today, we will share one of the science tasks, which is for a 5th grade student, and that is like mystery substance investigation. So this task is designed to support the teachers in eliciting students' thinking. So before I take you to try the simulation yourselves, I will walk you through it step by step so you know exactly what to expect. So I will begin by showing what you see when you log into the interface and what appears on each page. So we will move through the interface together so the flow feels very familiar when you explore it on your own. So let's start with the task goals. So the screenshot you can see here, the initial scene inside the interface through which participants engaged with the simulation. So the goals are provided to participants at the top of the screen. In this simulation, the goals are centered on elicitation. That is, the participants are instructed to ask questions to elicit what the students did to arrive at his claim. They are also instructed to probe to understand why the student performed particular those steps that the student did in the investigation, to discover what conceptual understanding the student has and does not have regarding how to identify the mystery substance. Can you go to the next slide, please?
Shreyashi, there is a comment in the chat. Someone was
Yes.
asking if they could have a moment to read the directions here, and I just wanted to check in. That individual, I was just going to leave it up for just a couple moments
Yes,
and
yeah, of course.
wait for a second to see if everybody gets the moment to read it.
Yes, absolutely. And you will also get the chance to try out this simulation by yourself. So you will also get to see those instruction as well when you will try out that simulation.
Okay, I will go ahead and move on now.
Mm-hmm. Yes, okay. So this screenshot shows the next scene inside the interface through which participants engaged with the simulation. So this scene includes the background description of what the student has done before this simulation. The setting is like a 5th grade classroom where the student completed an investigation to observe and measure 5 properties of 6 different known substances, which includes a data table for this initial investigation. The final phase further defines the elicitation goal focused on learning about what the student tested and their understanding of the scientific concepts relevant to the investigation. So I will give you like 1 minute to read through this the screen so you can get some idea that what should be provided to you. So yes, I'm just giving a very quick overview about that. I think just to clarify. So this is the task is designed for the 5th grade student. So you can take a look the data table where the information provided to the students.
And just to clarify, the 5th grade student is the one that has the work shown in the simulation, but the simulation is designed for teachers to practice the skill of eliciting student digging, not for students to practice it. It's just the 5th grade student is the student in the scenario, but it's for a teacher to practice eliciting the student's thinking.
Yes, yeah, thank you, Jamie, for clarifying that. So this is it. It's mostly for the teacher, so we'll practice, but the background is provided about the student, so teachers can take the preparation for that. So this screenshot shows the next scene inside the interface through which participant engaged with the simulation. The task instructions are explained and the time available to complete the simulation is defined. So you can see like 4 bulleted points, which are like action steps for participants to consider to support the development a strategy for how participants will interact with the GenAI student, whose name is Caleb, and to achieve the task goals. And the final image you can see that is the student's claim for the identity of the mystery powder, which is baking soda. So giving you a few minutes, a few moments to take a look, and then we can move to the next one. Thank you, Trisha. So as since we have like a limited time today, so we won't have a like a separate preparation time for you to like while you will doing the simulation. As you can see, there is a like a 10 minutes timer, but we might not have like a time for you to provide when you will try this simulation. So that's why we thought that why not make it a like a group work. So now you will automatically placed into breakout rooms. Each group will have like a 7 minutes to work together and come up with 2 questions you would like to ask Caleb to draw out his thinking about the mystery substance investigation. Jamie, Indira, and I will also be joining your breakout rooms to listen in and also discuss your ideas as you brainstorm your questions. After 7 minutes, you will return to the main room. Then one representative from each group will post your group's 2 questions in the assigned section of part 1 in Padlet. So Trisha, would you like to show them that where they can like post their the questions they will draw out for Caleb's investigation? So as you can see that Trisha is showing you that you will see in the Padlet, there is a brainstorm and like a picture, and also there is the question where you can like add 2 of the questions you will come up with the discussion with your group, and you will post that after 7 minutes. So you will get total 7 minutes. So by this time we will assign you to the breakout room. So yeah, Trisha, can you just, okay, we can.
Has everybody been routed to the breakout rooms? welcome back.
Yes.
Others should be joining the room now.
Yes. I think all of yeah, it's still taking time. It's like 11 participants we can see.
Takes about a minute to get everybody back.
Yes, yeah.
And Trisha, you should be seeing the brainstorm question on the screen. Is that what you were seeing?
Yes, I think
Okay.
yeah, I can see it. Yeah.
Okay, good. Just wanted to make sure.
Yeah. So I think I have a very good conversation in the group, and they come up with really good questions. Not just these two questions they are right now adding here, but they have also some other questions they are interested to ask Caleb. And I say that please keep them with you while you will do the interaction with Caleb. Definitely try out those questions, and I'm really interested to know that what response they receive. So I'm glad that I can see some of, I think already some some questions are there. I can quickly read one or two before moving to the actual simulation and giving you that opportunity to try this out. So maybe, yes, yeah, I can you scroll up a little bit, Trisha? So I can see, thank you. So one question, that what elimination process did you use? Yeah, absolutely. You can ask that question, that how the elimination Caleb did for the investigation. So what are the physical properties that you observed that make you think it was baking soda? Wow, that's an excellent question. A great question for elicitation, that what the physical properties they have like observed. Which characteristics of the mystery substance is shared with the other substances? Excellent. Definitely you should try this out. And as I say that I'm love to hear that what responses you received from Caleb. What was the weight of the mystery substance? Yes, you can ask, because you can see that Caleb using the data table to respond. And so which properties are most important for determining whether or not the substances are the same? Yes, of course, you should ask this question and see that how the responses are coming from the Caleb. Are there any properties that you could disregard? Okay. And the final question, I can see that which properties would you prioritize in order to find out which is the mystery substance with the least amount of steps? Excellent question. As I say that I'm really looking forward. All those questions are really good structured question for elucidation, and I'm really looking for, we all are looking forward what responses you receive from Caleb. So moving to the next slide. Yes. Oh, okay. Yeah. Yes. Yeah, I can see it. So this is the screenshot. You can see that the last screen inside the interface that has two tabs through which you can engage with the simulation. After becoming very familiar with the task goals, scenarios, students' work, and task instructions, you can chat through written text messages with Caleb using the interface shown in the right side. The second tab is also available for you to review the student's claim again. So now you will have I think I will give you a few minutes to read through. Trisha, do you think that you can go back and just, so if anyone is trying to see the final, yeah. Yes, you can just take a look. So, and then we will move for you to give you that opportunity to try out this simulation by yourself.
We go ahead and put the link to the simulation in the chat so folks can do
Yes,
that. And
in the meantime,
and
yeah,
I would say, yeah, hopefully you can do it on your laptop or computer, as it's not mobile enabled at the moment. And if anybody's having any trouble getting in.
Does it work on iPad?
I'm not sure.
Okay,
Maybe.
we shall see. I'm on
Yeah,
iPad.
I mean, the iPad, if it's, I'm not sure, to be honest with you.
Okay, let's see.
Are you able to put the link in the?
yes, I'm
chat?
just
Okay.
adding it. Thank you,
Um,
Indira, for adding
Right.
it.
No problem.
And you don't have to put your real first name and last name. No.
Yes, and Trisha, can you just move to the next slide? Yes, so now as I said, you will get like 7 minutes to try out this whole simulation, and you can ask the question you discussed within your team, the group, and I know that those are like the two questions. You also have like other questions to ask. We are welcoming you to ask those additional questions to Caleb, interacting with him. So as Jamie also mentioned, this link is currently not supporting on mobile devices. So please open it on a desktop or laptop. So the timer, I will set the timer, and you will get a reminder before 1 minute. And so try this out. And if you having any kind of a technical issues are facing, please let us know so we can resolve it. And yeah, you can try this out, this simulation. So we can start the timer for 7 minutes right now.
And I will say, if you are in the Padlet and you are looking for where you could go to find the link as well, it is right here, and you can just click right on the icon and it will take you to the simulation as well.
So anyone having any issues like login to that interface, just let us know, please, so we can take a look.
Sorry, I think I'm missing something really huge. Can someone tell me where is the mystery substance and where is its characteristics? Because the whole task is coming with the assumption that there is a mystery substance. I feel like
Yeah.
a row
Did you
is
ask,
missing.
did you ask Caleb those questions?
I think this is part of the question that we are giving to Caleb, and then we're asking them to identify the characteristics. I don't think it should be.
So ask Caleb
Also-
what he did and what he learned about the characteristics of the mystery substance.
Or without having the mystery substance? So it's
So-
actually a technical question I'm asking. Where is the mystery substance in this chart?
It's not in the chart. It's one of the 6 known powders. One of the 6 powders in that
Oh,
chart. It's one of the 6 known ones.
and then
So he was given
I
a
feel like I'm
sample.
misunderstanding something here.
Yeah.
So that's why I'm
yeah.
like, okay.
Yeah, no, of course. So the students in the class were conducting a mystery substance investigation. Caleb was getting the mystery substance and he decided to do some testing on it. He could test whatever properties he wanted. And he came up with his claim. So, and you saw his claim was he thinks it's baking soda, right? That's one of the 6 known properties. So you're just trying to
So,
elicit his thinking of like, how
Do
did
we
he
have
figure that out?
observation? Do we have observation of what he saw? That's the
No,
row
so
I'm talking
you have to
about.
elicit that from him. So that's part
Oh,
of in
so the
your
whole thing.
conversation with him, in your text with him, you can elicit that from him of like, what did he see? What did he do?
Oh,
What were the
thank you.
characteristics that he observed, right? So that's the information you're missing, right? That's part of what you want to try to elicit from him.
Mm,
Yeah.
okay.
Yeah. Are you in there? Can you ask him?
Yeah, I'm there. Okay,
Yeah.
thank
Okay.
you.
Okay. Yeah. No problem.
So all right, time is up, like the 7 minutes, and we also have like other parts to talk about. I would like to ask everyone to come back to this main room and we can share that what the interaction you had with Caleb, what questions did you ask, what responses you received. Definitely we can know, we can learn from you what you did. So as I say, that time is up. So I would like to know that if everyone is here, so just you can say hi, yes, or like and thumbs up, just to make sure that you are back from the simulation to this room. Yes, I can see the thumbs up that yes, I can see that you are coming back. So, all right, as you have completed the simulation, would anyone like to talk about the question you particularly asked and what the response you received from Caleb? Anyone, you can just use the Zoom chat and you can also unmute yourself to say that what particular question you asked to Caleb and what responses you received. Yes, please go ahead. I can see a hand up. Yeah.
All right. So I asked Caleb the following questions. I said for question 1, what physical properties did you observe that made you arrive at this conclusion? And Caleb's response was that smooth texture, white color, 24 grams weight, bubbles with vinegar, and clear when mixed with water. Then I move ahead and say, what physical properties among the listed ones have no influence on your decision? And Caleb said, I'm not sure I agree with that idea. Then I reframed the question. I said, what is the most important property that helped you to arrive at your answer? And then Caleb responded, I want to be like a thorough scientist. So I think that all properties listed in the table are important and will help me help me sure of the identity. So then I said, do you think weight plays an important role in your decision? Caleb said, yes. If you were to save time, that's my question. If you were to save time, which of the properties would you rather not consider? Then he says, I will be like a thorough scientist, and this only works if I use all 5 properties. Using less than 5 doesn't work.
Mm-hmm.
Then my last question, I said, how easy did you find the exercise?
Mm-hmm.
Caleb said it was pretty easy
Mm-hmm.
because I just tested all 5 properties and matched them to the table.
Mm-hmm.
So that was my interaction with Caleb. Very interesting one.
Yes, I would like to say you asked really good question to, like, elicit student. I mean, Caleb's what Caleb's did, understood, and like it all those questions are really great questions as part of the elicitation. But now I have a question for you. So did the responses match what you expected, or you expect something else from Caleb's to respond in for any of your question?
All the questions match my expectation except one,
Mm-hmm.
where Caleb says, let me look for the question. Where it says I would disagree with you. I want to just a moment. Yes, when I asked the question, what physical properties among the listed ones have no influence on your decision?
Mm-hmm.
So Caleb's response was, I am not sure I agree with your idea. So this looks like these common properties of AI in terms of hallucination. I don't think Caleb really understands the question. So Caleb just generates a random response that really doesn't match the question. So it's like it was a kind of hallucination on the part of the AI. That's the only question that Caleb really didn't answer according, I mean, the response doesn't represent what a regular student in the class would have given. A student would have probably asked for more explanation or said no idea. So
Yeah, absolutely. I think I got your point, that how you say that that the response you expected from Caleb, it does not seem like that a real student might respond like this way. Absolutely, we can take a look on those responses for you. The later on, we can also, as we are developing this task, we are refining it. Definitely, we can take a look that if those are doesn't look like a real students' responses. So just one.
I'm gonna add on to that because I had a similar question and
Okay.
response which was like, 5th grade, no. It's like the response was other scientist thinks all the properties are always important. You're not going to get that from us, a 5th grade or student. They'll try to explain something, but that won't be. That also picked my mind to that. I was like, no, it's so machine. It comes off so machine. Like you can tell it's not doesn't simulate the real life classroom.
Yes. Okay.
Yeah.
So you notice that like some of the
Yes.
responses are not real
Yes,
classroom
they're not
stories.
realistic. Yes, they're
Okay.
not realistic.
Okay, that's a good notice, I must say. So I have a final question. Anyone anyone can respond to that. That is that what did you notice about Caleb's understanding that while you interacted with him? So what the understanding Caleb's has like for particular this investigation? Anyone would like to share?
Like understanding of Caleb as a student, as a person.
Yes, Caleb's understanding. Did you notice anything that this is particular thing Caleb's understands really well?
Just following directions, the way he followed the table, the properties, and the answers were always like in that box of the properties of what he did. When I asked a question of something to think outside the box, he didn't have an answer to that. He was only saying, goes back to like, this is what I did. Whatever you're asking me, I don't know. So it goes back to, this is what my properties were, and I cross-checked with what I have and the properties, and I decided this is it. So he didn't try to give the beyond what was given. And then I even asked a question of like, what challenges did you experience throughout the process? Like, I looked at my data and nothing. It was okay. So I was like, no, a student would give you stuff and say, maybe at the beginning this happened, or I had things mixed up. The only challenge actually Caleb said was being able to measure correctly.
Okay, okay.
Yeah.
That's absolutely. So I would like to answer your questions, but for that you have to do that the very short reflection activity. So Trisha can show you that where you will get those all those questions, and I can share the link with you as well. So what you have to do, those the questions are, you can see in the Padlet, and there are like 3 questions you have to read through and just have to identify is that the correct or incorrect. So here is the link. I'm also posting once again, so you can if you need to scroll up, but yeah, you can just get this the link here. So the first question, so the questions all you have, so the profile we build up for this scale up. So it's not like a standard 5th grade student's profile with understanding, with a very good understanding, but this scale up, this profile has some kind of understanding and also a level of misunderstanding as well. So let's see, the first question is for you, that the student understand that the mystery powder must be a match to one of the 6 other powders that he already tested. So is that the correct or incorrect? So I can see just one person added your vote. Maybe, yes, you can just add that. What do you think that, do you think that Caleb understand that the mystery powder must be a match to one of the 6 other powders that he already tasted? So 3 votes we can see. We will wait a few moments. And we will, yes, I think I would like to know everyone's view on that. Okay, the 5 votes, and you can, we can see that like all of you said that the response is correct, that, right? Yes, that's true. So this is true about the Caleb's understanding. He understands that mystery powder must be a match to one of the 6 other powders that he already tested. The next one. So the next question is, the student understands he could have done fewer specific tests and still identify the mystery powder as baking soda. That's true. It's incorrect. So actually, the Caleb does not understand that he could have done fewer specific tests and still identify the mystery powder as baking soda. And that's the reason you are getting that he responding that he's a thorough scientist. He will use all the properties to identify the mystery powder, the mystery substance. The next one. So the next one is, the student does not understand that weight is not useful for determining the identity of the mystery powder. So some of you might be able to ask this question, or some of might not able to. So this the student profile actually does not understand the weight is not useful for determining the identity of the mystery powder. So thank you for responding to all those questions. I would like to move to our next slide. So that's all about our part 1 and trying this out, this simulation. So if you have any further questions, as you mentioned some of the feedback, please reach out to our team to share more, and what do you think about it. So we have like a question answer. You can post the question or like thoughts. You can share that on part 5. So now I would like to move to our part 2. Someone really asked me that what is really happening behind the scene. So while you are trying this simulation, you might be very interested to see that what is really happening behind this scene of this simulation. Can you go to the next slide? So you can see 2 of the pictures. So one of the picture, the left side is like the chat you write before you did the chat you did with the Caleb, and the right side, the picture, you can see that the image is most likely how the whole thing processed. So the simulation runs on a web-based platform that connects securely to Microsoft Azure, a cloud computing service which we used, that hosts powerful AI models such as GPT-5. Particularly, we updated our current task with GPT-5. When teachers interact with the simulation, Azure allows the system to send their messages to the AI model, which then generates realistic student-like responses. So when a teacher types a message, the system adds it to a structured prompt. We know about this structured prompt in our following slides. That helps the model understand the classroom context. The model then predicts and sends back an appropriate student response. So each new response builds on the previous messages, allow the GenAI student to stay consistent and context aware throughout the discussion, just like a real classroom interaction. So every interaction between the teacher and GenAI student is recorded. After the session ends, the complete chat is automatically saved into a Excel file so participants can review or analyze their teaching moves later. The next slide. So the chat agent for the simulated student was developed using OpenAI GPT-5 model. The simulation was based on an earlier human-led simulation. And as such, that human-led training protocols that we were adapted as prompts for GPT-5 model for this task. So I will repeat one thing I mentioned in the earlier slide. So that is, I say that when a teacher types a message, the system adds it to a structured prompt that helps the model understand the classroom context. The model then predicts and sends back an appropriate student response. So what does the system, what the system does? So the system uses prompt engineering to simulate the student responses. So I would like to know, is there anyone familiar, anyone heard about this term prompt engineering? So you can just write down in the chat, in the Zoom chat, that if you are familiar with the prompt engineering with this term. Oh, wow. That's great to know that. Yes, I think the prompt engineering is really getting that kind of attention in GenAI, and we are also learning about it. So the prompt engine, wow, it's good to see that a lot of you know about or being familiar with this term prompt engineering. So prompt engineering involves creating effective prompts that guide AI models, such as like large language models, to produce accurate and relevant responses. So in this task, each time a teacher sends a message in the simulation, the system sends a single structured prompt to GPT-5. So the prompt includes detailed instruction for how the model should generate its response, supported by few short examples. And in the following slides, I will provide a more detailed look at these prompts. The next slide. So this slide shows the beginning of the system message of the first prompt, which tells the model to pretend to be a student and how to respond to the teacher. So here it specifies the role to play and provides context by describing the investigation the teacher has completed, the data the student collected for the 5 properties of the 6 known substances, the data the student collected for the 5 properties of the mystery substance, the student's claim for the identity of the mystery substance. So this part of the prompt is then followed by more detailed instructions and a more detailed description of the student's background, knowledge, and thought processes. The next slide. In addition, the prompts provide information about what the student does and does not know and what they can and can't do, and some of which is shown in this slide. So for example, it states that the student can investigate the 5 properties of the 6 substances and the mystery substance and record their observations. They can, Caleb can identify the mystery substance by using the data table to find the which known substance has all 5 properties that match the mystery substance properties. Caleb does not understand how to prioritize the most useful properties for discrimination in the investigation, because he thinks that a good and thorough scientist always tests every property just to be sure. And Caleb also does not understand how to decide which properties are not at all helpful for discrimination, because they are very mechanical in their process of using the data table and testing all 5 properties of the mystery substance. For example, once the student can see that all the 6 substances are white and that the mystery substance is also white, they should, like the Caleb should have has been able to assert that color is not very useful properties in this investigation. But Caleb cannot do that because it's not a part of his profile. The next slide. So this prompt is also supported by a few short examples from 3 conversations. So this slide shows the beginning of one of these conversations. So these few short examples include input that we expect to receive from participants and what we want the model to say back. So the purpose of including these few short examples like this helps the model respond to a real person in the same way. The next slide. So I think I did a little rush go through that, and because I think we also don't want to give you a very deep understanding. We try to give you a very overview of what is really happening behind the scene. So if you have any questions, any thoughts, please share that in the Padlet link. I can share that link with you. And reach out to our team if you would like to interested to know a little bit more about this whole process. We would love to share that with you. So that's all about this part 2, what is happening behind the simulation. And now I would like to hand it over to Tricia to continue this session.
Sure. Thank you so much, Shreyashi. Thank you all for staying along with us. Now we're going to kind of move into the next step where we're going to talk a little bit about a pilot study that we did. And then we're going to give you guys the opportunity to actually look at a particular pilot study participant's transcript and think a little bit about the rubric that we developed and looking for the productive teaching moves that we identified based on this particular activity. So what I'd like to talk to you about now is the somewhat small pilot study that we did. We chose a convenient sample of 19 participants across the United States. They participated in the study during the summer of 2025. About 2/3 of the sample identified as female and white. Participants varied in age, with most of the participants between the ages of 35 and 64. 79% of the participants had previous teaching experience, and with most of them having about 4 to 10 years worth of teaching experience. And finally, 58% of the participants reported that they were at least a little familiar with using digital simulations or AI-powered tools in educational contexts. So the process that we used with these pilot study participants is the data collection involved 4 main steps. First, the participants accessed the GenAI simulation platform, just like you did, and they reviewed the written materials to learn about the scenario and what they should do to prepare for and engage in the simulation, just like you were able to. Then each participant prepared for the simulation by reviewing Caleb's work and looking at Caleb's claim, and then brainstorming questions that they could use to elicit the students' thinking about how they determined what the mystery substance was and the conceptual understandings about the properties of matter that Caleb had, just like you guys thought about and brainstormed with Shreyashi. Third, each participant then engaged in the text-based chat with Caleb, and the engaged with Caleb, the 5th grade student, and elicited his thinking about what he did in his investigation, and elicited his evidence-based reasoning, and tried to figure out what was Caleb's understanding and misunderstanding. Once they completed the total simulation, they would click end chat, just like you guys were able to, or you could have if you wanted to. And at the time when end chat is clicked, the interaction is recorded and transcribed as a conversation that is exported into an Excel file, like Shreyashi explained. Each participant then completed a post-simulation survey online to provide their feedback about the simulation's authenticity, usability, and usefulness, and to share what they learned about Caleb's thinking. To learn more about the analysis of the post-simulation data, please feel free to reach out to our team and we can share more details. We also have a NARST proposal under review related to the work regarding the post-simulation analysis. So now I'm going to talk to you a little bit about the behind the scenes of what we did once we received all of the 19 transcripts from the pilot study participants. We evaluated the transcripts and then we established a rubric for the most productive teaching moves and some teaching moves that we thought were less productive in eliciting Caleb's thinking in the simulation. The rubric contains 6 productive teaching moves and 2 less productive teaching moves. But for the purpose of this workshop, we're going to focus on 2 of the productive teaching moves, and we may not have time to get to it during this discussion, but we have included those in the Padlet for you at your convenience. You can go ahead and explore the less productive teaching moves as well and kind of practice to see if you can identify those. So the first thing I want to tell you about is that the transcript data was collected from the 19 participants and then evaluated using the teaching move rubric. And then the rubric was used to be further refined as we went through over and over again through more and more transcripts. And then once we started to kind of concretize the rubric, we were able to then add positive examples and then non-examples to the rubric to further refine the rubric as well as the coding process that our team utilized. So now we have a Padlet question that I would love to ask you before we get into the moves that we identified. I would love to ask you, what teaching moves do you think would be productive for teachers to use in this simulation to elicit Caleb's thinking and understanding? So you can get to this question multiple different ways. If you are using your phone, you could use the QR code here. The link to the actual questions is also linked right here in the PowerPoint presentation. And if I go here and I come down to the teaching idea post, I'm going to expand that and go right here so that you can kind of see it more expanded. And so you can see the question right over here, and I will give you 1 to 2 minutes. Please go ahead and please share in these comments section some ideas for things that you think are productive teaching moves that could be utilized to elicit Caleb's thinking. And if anybody's having trouble finding this or finding the link or the QR code, please don't hesitate to just come off mute and let us know. I am not seeing anybody adding any comments. I'm just wondering if anybody is having trouble finding it, or Trashy, I don't know if you can drop the link to the actual question as well, please, in the chat.
Yes, I posted the link, which if you can click on that, you will directly go to that the question.
Yeah, and there is one response here.
Oh, wonderful. Thank you. So one of the individuals said, elicit the evidence-based reasoning he used to generate his claim about what the mystery substance is. Yes, yes. Be looking to see if the teacher does that in some form or fashion, right? It could look very different in how they word the question, but the idea of does the teacher elicit how Caleb identified the mystery substance, what Caleb's process was. Anybody else want to add some additional potential productive teaching moves they think they would be looking for from a teacher to use in this interactive simulation?
I can't seem to type, but I think if it's okay, I can share.
Sure, that would be wonderful.
Yeah, I think this is not a good teaching move so per se, but learning Caleb as a student, I think direct questions, like questions that open-ended but within the scope of the experiment. If you ask to think outside the box, I thought that won't be productive to elicit thinking because Caleb was just confined into that experiment. So I'm thinking it's good to know as a teacher that I need to try to stay within these boundaries.
Mm-hmm.
Yeah.
Mm-hmm. And I'm just going to check my understanding too. You're making me curious. So if you were trying to strategize, if I'm understanding what you're saying, you're thinking first you might pose a question that's maybe a little bit pushing the boundary, but if you detected that Caleb was kind of using this mechanical process, you might then further refine your elicitation to keep within the boundary and to kind of go deeper and less broad. Is that kind of what you're saying?
Yes, yes.
Okay. Okay. I understand. Thank you so much for sharing. Anyone else? Feel free, please, to just come off mute if you don't want to post it in the comments. I'd just be really curious to hear your thoughts.
Before I go, because I'm driving, I'm going to drive. I'm going to say another one is to make sure like the process, asking about the process of his conclusion or his experiment, that seems to be a helpful prompt to elicit thinking.
And I'm going to go ahead and add like your comment for you, because I think that both of these ideas that you're sharing would be really helpful for us. So you said the process that Caleb is using in his investigation. And then you also mentioned determining kind of early that Caleb is kind of confined in his thinking, and then maybe tailoring those. To that end. Anyone else care to share anything before we move on? Okay. All right. I'll go ahead and take us back to our presentation. And I'm going to go ahead and talk about the first productive teaching move that we identified in our rubric. And the first one is related to the process that Caleb is using. So what we were looking for is if the teacher elicited from Caleb how he arrived at his claim for the identity of the mystery substance. So we were looking specifically to see that the teacher elicited from Caleb the process that he used to compare all 5. We were really looking to make sure that the teacher went through and elicited all 5. Now that could have been in a very long series of dialogue back and forth and back and forth and back and forth, or it could be just a very straightforward, very open-ended question that actually elicits Caleb to say his total understanding in one response. So to that end, we provided you here with an example of that type of dialogue, where the teacher poses a question in such a way that is open enough where Caleb actually ends up responding in totality, meaning he actually says, I looked at all 5 properties of the 6 substances, then I looked at all of the properties of my mystery substance, and that's how I matched them. So this is a very, what we consider kind of an exemplar of a particular teacher elicitation that is positive for this particular teaching move. I'm going to go ahead and move on to the next productive teaching move that we identified. And this one is, we were looking for the reason why Caleb thinks that he has to use all 5 properties. So this, we were looking to see if the teacher kind of starts to notice that Caleb is really using the data table and relying on the data table and using it to guide solely, and really not using his ability to like use a process of elimination with respect to realizing that maybe color and weight aren't that helpful. And so here, this type of dialogue between the teacher and the student can kind of present a little bit different in different transcripts. So we've provided you with 2 different examples here where the teacher is eliciting, you know, why, Caleb, did you feel that you had to use all 5 properties? And you can kind of see these are different types of responses that Caleb is giving based on that elicitation. However, either of these examples does surface this misconception, but sometimes you have to dig a little deeper to realize that Caleb truly thinks that all 5 must be used, even when pressed. And so that's what we're looking for from the teachers for this productive teaching move. So now what I'd love to do is give you the opportunity to go into breakout groups. We're going to give you 10 minutes and we've got a shared transcript for you from an actual pilot participant from the summer 2025. And what we would love for you to do is go ahead and read that transcript basically from start to finish first, so you develop the context for the whole conversation. And then we would like you to look at those 2 productive teaching moves that we just discussed, and I'll share with you how you can make sure that those can be in front of you. And then look at the transcript and see if you can identify instances where you either see a running dialogue, maybe it's 5 or 10 different utterances, an exchange back and forth between the teacher and Caleb, or maybe you see a really good single open-ended question from the teacher that elicited from Caleb one of the productive teaching moves that you were looking for. So what you're going to need for this 10-minute breakout group is you're going to need to open the shared transcript link in the Padlet. And then you're going to want to be able to be viewing the 2 productive teaching moves that you're looking for to support your group's discussion. So if you take a look at this slide, you can see that there are 2 QR codes that will route you directly to the place that I would love for you to please add your comments as you're having your group discussion. And if you don't have a phone and you just want to be able to follow the link, I will go ahead and show you now in the Padlet where you can find that at. So coming down here, you can see that here is the timer for us. Here is your first productive teaching move so that you can open this up. And if you're curious and you would like it to be bigger for you on your screen, all you have to do is select the ellipses and click on open post in new tab, and it will actually create a bigger version for you. And it provides you with the ability to more easily add your comment right here as you're, noticing things and thinking things and discussing as a group. The same is also true for productive teaching move number 2. If you want to click on the 3 ellipses again, open that one, and it will also take you to an expanded version so you can more easily see the transcript examples and you can add your comments here. Now you may be wondering where the shared transcript is. All you have to do is click on it and it will take you to the shared transcript right here so that you can begin reading the conversation between Caleb and the teacher. And then you can toggle back and forth between the teaching moves and the transcript and see if you can identify the instances where you feel there are positive examples for either one of these teaching moves. So I'm going to go back to the presentation now and say, what I would like for you to do, please, is when you go into your breakout rooms, discuss with your group which utterances that you've identified. And then after 10 minutes, you're going to be routed back to the large workshop group. And please also enter into the comments for each of those individual teaching moves some examples of things that you think are positive examples of that particular productive teaching move. So now I'm going to automatically route you to the breakout rooms. But before we break, I just want to pause for a moment and ask if anyone has any questions. Please feel free to come off mute, ask anything, or type anything in the chat for a moment before we go to our breakout rooms. Okay. Hearing no questions, I'm going to go ahead and put everybody into their breakout rooms. And it should route you very shortly. Okay, so I'm just kind of waiting to see if we have everybody back. I think we're waiting for Shreyashi and Indira. I see, so I'm on, okay, it looks like we have everybody back, which is wonderful. And so now what I would love to do is just give everybody the opportunity to kind of talk a little bit about the experience. So I'm going to go ahead and share my screen again. And give it just a moment, please. And so you had the opportunity to kind of talk in your group and you looked at the transcript and then you were kind of thinking about these two different productive teaching moves. And we had a wonderful, rich conversation in ours. And I was just wondering if, Jose, if you'd be willing to kind of come off mute and talk a little bit about some of the things you were talking about regarding the transcript and what you noticed and things like that, please.
Yeah, so one thing I noticed in terms of eliciting students' ideas was that the teacher had an interesting transition there from like asking more procedural questions, like trying to understand the step-by-step process that the students followed to come up with the mystery substance. But then at the end, she or he added some questions related to like kind of extensions, like what will happen if we do this differently? Will you do this in a different way? Like what if we switch the steps? So those kind of questions are, I think, going beyond eliciting students' ideas, initial ideas, but are obviously related to it. But I thought it was a good move there to make that little transition to have the student think in a different way and provide more critical thinking opportunities.
Okay, thank you so much for sharing. Based on what Jose is saying, do others have some thoughts they'd like to maybe share regarding what they think about what Jose said? Or maybe you would just like to share some of the things you noticed? All right. It doesn't look like anybody else wants to add additionally. When I come in and look at the comments, I haven't been able to see if anybody has added any comments yet. I will hit refresh just in case maybe that's what I need to do for each of these. But I understand that you may have needed a little bit more time to do some thinking, and that's okay. And I will go ahead and move us on in the conversation then because I'm watching our time and I want to make sure that I give time to my colleague to go ahead and discuss kind of the next part that we want to make sure we get to with respect to this workshop. So I'm going to go ahead and go back to the slideshow presentation and kind of advance us to Indira, please let me know which slide you wanted me to stop on. I'm trying to remember. That one?
We can just go to the previous one. That's the slide number 47, which is brainstorming and using use or adapt. Yes, this one.
Yeah.
Okay.
And Indira, I was gonna say
Since
maybe not do it on the Padlet. We could just talk since we're a smaller group now.
yes, exactly.
Yeah. Perfect.
Yeah. Since all of us explored the GenAI simulation and we also went through the transcript, let us think of these transcripts as documents of real-time learning process because they actually capture the finer nuances of student thinking and teacher moves and flow of the scientific dialogues in a classroom. So basically, these transcripts they actually they are windows to the pedagogical dynamics in the classroom. So I would like you all to quickly type in the chat box or perhaps later use the Padlet and answer on how could these transcripts be used as tools for reflection and discussion in science method courses as well as for professional development? And I give you just half a minute to use the chat box and share your responses.
Or maybe just come off and mute because I don't know if we have time to.
Yeah, you can
type.
come off
I was
mute
gonna
and-
actually ask Jose if maybe he could start, because Jose, you had some thinking you were doing already about how you might integrate something like these types of tools, or how you might use them
Yes.
in your course.
Yeah, no, I was sharing earlier that that I think this idea is just brilliant because like I use a lot of teaching scenarios and transcripts in my science method courses. But the problem is that those are not interactive. Like the students don't get any like feedback from students. They are just limited to um the whatever is presented to them on that scenario or transcript. So this gives like a step beyond because like they can actually interact with a student, at least text-based, which I think it's great. It's a low stake situation. They can do it individual. I can see them do it that individually with a partner. I can see us doing as a whole group on the screen. Like I can see multiple ways to implement this in the classroom for different purposes, from different topics, since I'm assuming you have the possibility to manipulate what are the students' backgrounds. So you can even have the pre-service teachers to choose what kind of students they want to interact with based on which students they think they might have access to in the future. So yeah, I think you have multiple applications. I think it's just a brilliant idea to implement.
Right, right. Thank you so much, Jose. All right. Now, owing to time constraints, we just go to the next part, wherein since we are conducting these AI studies, Trisha, can you just go to the slide number 56, which talks about participation surveys? Yes, this one. Here is a study invitation for every one of you. And now we are inviting pre-service and in-service primary, or rather elementary teachers to participate in research conducted by us. And the research is designed to evaluate the GenAI powered digital teaching simulations and personalized feedback tools that support learning. So if any of you are interested, please do fill in the intake form. It is there in the Padlet. If you go to the part 5 of the Padlet and scroll down, you can see the research participation opportunity part. And that is where the, yes, yeah. Yeah.
And I would say that this research opportunity is for elementary pre-service and in-service teachers. So if you're not, I think currently an in-service, pre-service or elementary in-service pre-service teacher, it would be for you to share with pre-service or in-service teachers you work with, and they could get free access to try out a couple of these simulations and, provide us with some feedback on what they thought about them and how they could be improved. I just didn't want there to be confusion in DERA, because you said for them to go and complete it themselves. But I think the folks on the call are not currently elementary pre-service or in-service teachers.
Yeah, I'm sorry for.
Yeah, no problem.
Yes. All right. Okay. So with that, we come towards the end of the webinar. Thank you very much, everyone, for being a lovely participant. And please do add your feedback. And here is a link. There's also the link to the repository for webinar materials. On the Padlet, we have added the small QR link, which will take you to our Google Drive, wherein we have saved the transcripts and the webinar materials for your future use.
Yes, there are about 10 additional transcripts that Jose, Sarama, and others, if you wanted to use them in your courses with your teachers, or maybe you wanted to just take a look at them yourselves, or use them in any kind of even, low-key peer conversations, they can be used and they're available for you. So we hope that it's helpful, and we're so excited to hear more from you guys. So please feel free to keep the conversation going with us. Thank you so much for joining. I just will turn it over to my colleagues to go ahead and share their ideas and parting thoughts.
Yeah, thanks so much, everybody. Really appreciate it, and feel free to reach out at any time.
Thank you, everyone.
Yeah, thank you for joining us today. Yeah, thank you.
Have a wonderful evening, afternoon, morning, whatever it is for you and your time.
All right. Tricia, you can stop the recording.